Hello everyone, my name is Ashish and my section is A and batch A2. I am in Bangalore Institute of Technology College in third sem second year from Computer Science and Engineering department. In my digital design and computer organization subject, I have a project name is SR flip flops, which is I am going to explain what is SR flip flop and how does it work in this presentation. So first let's go through the outline of this presentation. Then we will go through the explanation of the present in this presentation. So outline. In outline, what is I'm going to explain is what is flip flop and what is SR flip flop, and I will give a little knowledge of latch using NAND because to explain SR flip flop we need NAND latch because latch can be formed using NOR gate or NAND gate, but in this presentation I am going to use only one NAND gate and working of SR flip flop, application of a SR flip flop, and advantages and disadvantages of SR flip flop. Okay, so first let's go through what is flip flop. Flip flop is a more advanced version of latch. Flip flop more advanced version of latch. It is used to store binary data. Remember that it is only used to store binary data. This is 0 or 1 only. We can't store our name or like English alphabets or Hindi alphabet or any other language alphabet, or we can't store that kind of data. We can only store binary data in flip flop, but it has additional property of being edge triggered. What does it mean by edge triggered is latch works on low and high. If we apply clock basically means signal. If we apply low and high, latch works here only, high or low, but flip flop works at here. When we change low to high or high to low, it is known as a raising edge, and this is known as a falling edge. Flip flop works here only because it's the shortest period of time. Mm. Unlike latches, flip flops are triggered by clock signal. I told you what is clock signal. Clock signal is just a type of signal which is used to trigger flip flop, and they only changes their output state at a specific edge, known as rising edge or falling edge. Sorry, and falling edge. Flip flops are more commonly used digital circuit for synchronous operations where precise timing is required. Now that where we required precise timing in our computer or in digital circuits in anywhere, we use flip flops. Common types of flip flops include SR flip flop, D flip flop, JK flip flops, and T flip flop. Okay, so let's go through what is SR flip flop. SR flip flops means SR. First, let's go through what is the mean of SR. SNR. Okay, I'm going to little bit down. Okay. SNR. S means set. Whenever we say in a digital design or in electronics, a circuit is set, what does it mean is a circuit is giving output as 1, irrespective or its combination or anything. The complete whole circuit is giving output 1 as 1. And when we say a circuit is in reset mode, what does it mean is it is giving as output as 0, irrespective of what circuit design its internal combination or whatever. The complete whole circuit is when is it reset mode, it is giving output as 0. Let me erase this. Okay, now here we can see that a flip flop has two input, which is known as set and reset. We denoted as S and R, and two output, which is Q and Q dash, which is known as complement of Q. when the set input is asserted, means set input is set to be 1 and r input set to be 0, the output becomes 1. I told you, like, the complete whole circuit giving is output is 1. Conversely, when r input is asserted, when r input is asserted and input is not asserted, means it is become 0, the q output becomes 0. Simultaneously asserting both S and R should be avoided because it can lead an unpredictable behavior. So we know little bit what is SR flip flop, how does it little bit work, but I am going to go deeper in the next slide. Let's first understand what is latch. So what is latch? The basic storage element called latch. As name suggests, it latches. It latches means what? If suppose there is a door and it latches. It latches means what? If something is inside that door, then it can't go outside. And if something is outside in that door, then it can't go inside. Means what? Ki if binary data, if data is stored in the memory, then it will be stored until and unless we apply some external signals or clock. And if something is not in memory device is stored, then we can't just store data without applying any signal or any external things. That's it means. And let's design SR latch using NAND gate. SR latch using NAND gate. So let's understand latch using SR latch using NAND gate. What is SR latch? Here you can see I am using two NAND gate, 1 and 2, which input is S and R and output is Q and Q dash. I'm not going to explain much about SR latch because this is not topic of my subject, and it will also take much time. So just remember this table to understand SR flip flop using NAND gate, SR latch using NAND gate. Okay. So when we apply S and R 0 0, it is not used because it leads unpredictable behavior. And when we apply S equal to 0 and R equal to 1, it gives as output as 1. It is known as set mode. And when we apply S equal to 1 and R equal to 0, it gives output as 0. It is known as reset mode. And when we apply 1 and 1, it stores, it holds data. Like if there is a q, then it give us output as q. And if there is a q dash or anything, like you can imagine like 0, if output is giving first, it is giving output as 0. If we apply S and R equal to 1 and 1, then it will give 0 output. And if the output, it is giving output as 1, and we apply 1 and 1, it will give only output as 1. Here will give 0 because it's complement. And when we apply when there is output is 1, it will give as output is 1. 0 and 1, it is complement of the, means when we apply S and R equal to 1, it behave like memory, it holds the data. So now you know the SR latch using NAND gate. Let's go through SR flip flop using NAND gate. Here you can see the circuit diagram of SR flip flop. This part you know, and this table you do know now. Here what I did is I used two NAND gate, 1 and 2 NAND gate, and I have given a clock. It is represented CLK. I have written full name. It is not like that. If you write it, it's okay, no problem. Clock means here clock is what? Here I am giving a signal. It can be like it is triggered means it can be like I am giving input, or not triggered means sorry, if clock is triggered, then it is taking as input as 1, and if it is not triggered means it is taking input as 0. Here I have added 2 NAND gate, extra NAND gate, and this complete whole sequential circuit. Why I am calling it sequential circuit? Because output output of the current circuit output of the current circuit is depending upon present input as well as past input. As you can see here, this is the past input for the current output. So it is a sequential circuit, and flip flops and latches are made of sequential circuit, not using combinational circuit. So first let's understand. First, if we do not trigger the clock, if we not trigger the clock, what will happen is, if we not trigger the clock means we are not giving any information to that flip flop. We are not giving any information to that flip flop, then it will not work. Like, it will be remain. If it is giving output as q, then it will give q. If it is giving output as q dash, then it will give output as q dash only. It will not change. Means if you are having a hard drive and you are not plugging in your computer, then how it will change? Plugging in computer means what? You are giving some data, or you are giving some input in that your hard drive. So it is like that. So here clock is not triggered, which we are not giving any input signal, then it will remain same. And when clock is triggered, means we are copying, or we are giving some input to that hard drive, or any flip flops. Trigger means that if it is trigger, then there will be 4 combination. There will be 4 combination, because there is also S and R, which is taking input as. Then first let's go through. First we will understand 0 1, then 1 0, then 0 0 and 1 1. Okay, so first case 1. Let's suppose S is 0 and R is 1. We are covering this. This case first. If S is 0 means S is 0, and R is 1, and we have triggered the clock, means it is taking as 1 and 1. And here we have to apply the fundamental principle of NAND gate. And what is that is, when there is one input is 0, then it will give output as 1. We don't have to see other input in NAND gate, because you can see I'm going to draw the truth table of NAND gate. Let's suppose this is A and B is input and Y is output. 0 0 0 0 1 1 0 1 1, and we know the output of this. We know the truth table, like it is 1 1 1. This is 0. As you can see here, if any input is 0, then it will give output as 1. It will give output as 1 only. So if we apply here case, let's suppose in case 1, if we apply S equal to 0 and R equal to 1, S equal to 0 and R equal to 1, and clock will be triggered, means it is taking a 1 input. So what will be its output is this. Its output will be 1, and you can see this is the NAND gate, then it will function as a NAND gate, and its output will be 0. And in this also we here R is 0, then we don't have to see this input, because it will give 1, and this 1 is applied as input of this NAND gate. When S is 1, and we are also giving this as a input is 1, because this is a sequential circuit, not a combinational circuit, and flip flop is made of sequential circuit. So we are giving output as feedback, because you can see this is the, if we take as this as a present output, then its present output depends what? Present input as well as past output. So 1 1 it will give 0. Now you can see here q is 0 and q dash is 1. It is complement of each other. As I told you, as you can see it in this truth table, if we are applying 0 s equal to 0 and r equal to 1, then it is giving us 0 output, and it is a reset mode. Let's go through second case. First let me erase this. Second case, we are going to take this one. Case second. Let's suppose s equal to 1 and r equal to 0. S equal to 1 and r equal to 0. Clock will be 1. Okay. Now here you can see r is 0. What we have to do is, we don't have to see this, or you can see, because here we are having both the inputs. Then we can see, we can use our NAND gate truth table, but we don't have to see, because we know if any input is 0, then output will be definitely 1. We don't have to see, and in this case we have to see 1 1. It will give as output as 0. As s is 0 and r is 1, you can see, then we don't have to see this input, because this is NAND gate, and it we know its characteristics. When any input is 0, it will give 1, and this output is fed as input of this gate. Then here, oh sorry, it will be 1 1 1 1. What it will give? 0. As you can see here, we are considering q only, not q dash. And you can see also verify q dash. This is q and this is q dash. Not cover. When we apply s as 0 and r is 0, when we apply s is 0 and r is 0, and in this case, let me erase first this, because we can't see. When we apply s is 0 and r is 0, it holds memory. Like if we if there is q, it will give output as q. We can verify that. If the output is q dash, if previous output is like a past output is q, it will give present output as q. And if previous output is q dash, it will give output as q dash. It doesn't depend on this. And this stage, we call it memory. It is holding the data, or we can say in precise manner, this is the memory, because it is not depending upon the present input. It is holding the data. If we have a hard drive, and we know it's stored data, it doesn't depend like what we are doing in that hard disk. We are applying signal, or we are giving any information, or putting any information in that hard drive. It stores the previous data. It doesn't matter in the present data. So now it is storing the data. Let me erase this. In fourth case, we never use fourth case. In the case of latch, we never use 0 0 first case, because it leads us to unpredictable behavior. Unpredictable behavior. Now you can see here, when clock is triggered, that means we are applied our hard disk to any CPU or any device or any circuit. It holds the data at when s equal to 0 and r equal to 0. It holding the data, and at 0 and 1, it will be a reset mode, and at when s equal to 1 and r equal to 0, it will be a set mode. And we don't use 1 1, because it leads us in unpredictable behavior. So this is about SR flip-flops. Let's go through its advantage and disadvantage. First let's go through its application, then we will see what is advantages and what is disadvantage of this. I already explained this all the things. You can read here like SR flip flop is a basic sequential logic circuit because we are not dealing with combinational circuit because flip flop is made of sequential circuits. It holds information as one bit. We can combine them to use so many to store so much data. 8 bit, 4 bit. We can make memory. Anything we can make. It consists of two stable state, often denoted as set or reset, or as S or R. The flip flop is two input S and R and two outputs Q and Q dash. When the S input is set as 1, the while R is not asserted, it is in set mode. And conversely, when R is input asserted 1 and S is not asserted, means S is equal to 0, the Q becomes output is 0, means it is in reset mode. Simultaneously, we can't do it because it leads an unpredictable behavior. SR flip flops commonly used in digital system for memory elements, latches, and basic control circuits. They can be connected using various electronic components such as NAND gate, small gate, and even transmission gate. So let's go. It's an application of SR flip flop. So applications of SR flip flop. SR flip flops find diverse applications across digital electronics because we know in digital era we can't survive without memory. Without memory we can't do anything. If we are doing, we have to store our data or information in this digital world. So we need flip flops, we need memory, we need latches to store data, to store our information. So enabling the implementation of various function and system, like you can say memory units, we use latches and registers. SR flip flops are the basic building blocks of memory unit like latches and registers. Latches and registers are essential for temporary storage of data in microprocessor and digital system. Here is another application is frequency divider and counters. Counters is the advanced version of latches or flip flops. We will learn in the next slides or in presentation. SR flips are utilize frequency divider and counter. These circuits are crucial in applications requiring precise timing, such clocks generation and event counting. State machine implementation. Machine implementation is another application of SR flip flop. An overview of the real world example. Here we can see where do apply in real world, like digital clocks. We use SR flip flops in digital clocks. We use SR flip flops in traffic light controllers, PLCs, programmable logic controllers employ SR flip flops for industrial automation and control. Memory cache system. Memory cache system which is present in CPU. It uses SR flip flops. Latches and register built with SR flip flops enhance data storage and retrieval time in computer memory hierarchies. So let's go through advantage and disadvantage of SR flip flop. Advantage and disadvantage of SR flip flop. SR flip flop offers several benefits but also come with certain limitations, because we do know like everything has its advantage and disadvantage. So like that SR flip flop also has advantage and disadvantage. It has certain limitations. We can't use everywhere. We can't do anything using only SR flip flops, impacting their suitability for different applications. What is advantages? Advantage, it's simple design. We have seen how its design is so simple. Like we have to use NAND gate, then it will be packed in a compact circuit. Fast operation. It is fast because we do use in cache memory, and we do know cache memory is the fastest memory in our CPU. Wide range applications like SR flip flop find utility in various digital applications, including memory units, counters, and state machines due to their versatility. Disadvantage. What is its disadvantage? Metastability issue. What is metastability issue is SR flops are susceptible for metastability, a condition where flip-flop enters an undefined state during transition, potentially leading enormous erroneous outputs. Erroneous output. We have seen, like, we can't use what we can't use zero in latches. It leads unpredictable behavior. In the case of SI flip, we can't use 1 1 because it leads us in unpredictable behavior. Asynchronous behavior. They can exhibit asynchronous behavior, making timing and analysis synchronization challenging in the complex regions, digital systems. So by this, we are going to see conclusion. In conclusion, SR flip-flops stands as a fundamental component in digital electronics because we have seen, like, without as flip-flops, we can't store all information or data. SR flip-flop is a component of fundamental component in digital electronics, offering both advantages and challenge its implementation. Thank you for watching the presentation.